Hello everyone and welcome to our new section which is called Dynamic Programming. Now before digging into this section, let's see what we will learn in this section. First we will learn what dynamic programming is, then we will learn different approaches in dynamic programming, and then we will solve different types of problems which can be solved using dynamic programming easily. So we will solve the problems that we solved in case of divide and conquer, but here we will solve that problems using dynamic programming. So the first topic is, what is dynamic programming? By definition, dynamic programming is an algorithmic technique for solving optimization problem by breaking it down into simpler subproblems and utilizing the fact that optimal solution to the overall problem depends on the optimal solution to its subproblems. Now let's try to understand this definition using a very simple example. Now let's say we want to solve this math question over here. So we need to find the sum of these series over here. So we simply add all of these numbers and find out that the answer is 7. Now let's say if we are asked another question like this, where we need to find the sum of these series over here. So what we are going to do over here is, we simply take the answer from the first problem, which is 7 over here, and we add 2 to this, and we find out that it is 9. So instead of adding these numbers one more time together, we are just remembering the answer from the previous problem and adding 2 to this answer over here. So this is the smart way of solving problems like this. Now in case of dynamic programming, we are also doing the same thing, in which we remember the problem's answer, and when we encounter the same problem next time, instead of solving it, we simply use the answer that we got before. So the logic here is, when we break the main problem into subproblems, we see that same smaller problem is coming again and again. So instead of solving it again and again, we solve it once and storing the answer for the next turn. So the next time when we encounter the problem, we simply use the previous solution. So if we compare the dynamic programming with the divide and conquer algorithm, we see that dynamic programming is the optimization of divide and conquer algorithm. Now we know that in case of divide and conquer algorithm, we divide the problem into subproblems and solve the smaller problems and combine them. Now in case of dynamic programming, we do the same thing. We are dividing the main problem into subproblems and then solving the subproblems. But here the only difference is that if the smaller problems come again and again, we simply use the solution instead of solving them multiple times, and this increases the efficiency of algorithm. Now let's see two main properties of dynamic programming. The first property is optimal substructure property, which we saw in divide and conquer algorithm. So here it is the same. Any problem that has optimal substructure problem, if it is overall optimal solution, can be constructed from optimal solutions of its subproblems. An example of this property can be Fibonacci numbers, where we can divide this problem into the subproblems. So as you can see, fib n equals to fib n minus 1 plus fib n minus 2. So this means that we are dividing this problem into the subproblems and finding subproblems and combining them together to find the solution for the main problem. So this property is same as the one that we have in divide and conquer algorithm. So here also we have this property. Now the next main property of dynamic programming is overlapping subproblem property. This property means if the solution of any given problem involves the same subproblems and solving of same subproblems multiple times, then this problem has overlapping subproblems. This means that instead of solving these same subproblems multiple times, we just use the solution of them. But in case of divide and conquer algorithm, we are calculating these subproblems again and again. Now if you look at this Fibonacci example over here, you see that, for example, when we find the Fibonacci number 4, we see that here Fibonacci 2s are repeating and Fibonacci 1s are repeating. So in this case, we are just calculating Fibonacci 2 one time and using it for the next turns, and we are calculating Fibonacci 1 one time and using it for the next turns. So when we are calculating them, we are storing the answer of these problems over here. So this means that when we solve this, for example, Fibonacci 2, we don't need to solve it again over here. So this improves the time complexity of the problem. So this property, overlapping subproblem property, makes the dynamic programming different from the divide and conquer algorithms. And this is advancement of divide and conquer approach. So hopefully you have understood what is dynamic programming, and we have learned two main properties of it. Now in the next video, let's learn two different methods of dynamic programming for solving any given problem. So see you in the next lecture.